My name is Ambad. I lead efficiency for Pinterest. And today I'm here to talk about tokenomics and efficiency with all of you all. So the first thing is, before we get into efficiency, we need to understand what the problem statement and business use case is. And as I see it, there are two specific concrete use cases here. There's product AI. This is your customer-facing applications. This is what you're able to make more revenue and drive more margins out of, and command a price premium at the end of the day. And the other set of use cases are internal AI use cases, your document processors, chatbots, coding assistant use cases. And they have to be treated differently because they come up with different constraints. For the product use cases, you have the ability to be able to drive a higher price premium, and therefore your budgets have to be in compliance with that. You have to provide a little bit more wiggle room, and they have to be growth oriented. On the internal AI use cases, you're probably looking at margin optimization. So this is just cost optimization for the company. And as a result, we need to understand that tokenomics is not just an absolute cost question, it's a ratio question. And ratio here is what we are all familiar with, which is ROI. And what we have to look at is what is the ROI for these two classes of use cases. And let's just be honest, the metrics landscape in the industry, in this space, is still a work in progress. There's a lot of new things that we're all learning together. And therefore, the governance cannot be so tight and restrictive that we are not able to innovate and experiment with new ideas. Who knows, there may be a next billion-dollar idea for your company sitting right with the help of AI. And therefore, we have to come up with an abundance mindset. And the abundance mindset here is basically saying, how can efficiency drive the headroom? So you have your budget set, let's say it's $100. How can you drive more tokens for that $100, the exact $100 that you had? And so what we think about is, one way to look at this is how can you have a structured approach to have efficiency compound at different layers. So efficiency is a very domain-specific item. Each one of these layers requires massive amount of engineering effort, and therefore, what we want to do is look at how can we drive efficiency at every single layer, which drives compounding at that layer and delivers more net ROI. At the end of the day, you get more tokens, simply put. So let's go through each layer. At the bottom layer, we have silicon and hardware. This has been delivering tremendous price performance boosts over the last couple of years. And whether these optimizations are coming from lithography, higher memory bandwidth, or just better instructions at the chip layer, they are all critical for you to leverage so that you can drive more tokens. The second part is what good is a chip and a decision that you've made for your company if you can't fundamentally procure it. And for that, you need to understand the chip that you selected also drives the underlying infrastructure. It drives the region and the zone and the data center that it can be allocated. It might require liquid cooling, which would require additional infrastructure that you have to prepare ahead of time. The third thing, and we go up the stack, we get into the inference stack. And the inference stack is the software, the actual software machine, which takes silicon and takes the billions of parameters of the model, combines them together to produce tokens. And here there are a lot of opportunities to optimize. For example, you could do KV caching, you could do prefill disaggregation with decode, and that allows you the flexibility to drive higher tokens. However, there classically been a method to optimize here called batching. So you just batch more requests together, and you'll be able to get higher efficiency. However, that is limited depending on what your use case is. If your use case is looking for lower latency and lower time to first token, you can't batch as much, and your utilization has to be limited because your use case demands such. Let's go up the layer. Let's look at model and quantization. Again, what model are you selecting? Is it a dense model or a mixture of experts model? Should you have higher parameter count or lower parameter count? Should it have different quantization for a certain amount of quality? These are all levers to think about and how you can drive more tokens and more efficiency at this layer of the stack. And finally, we come to the routing and the governance layer. This is where you apply your budgets. This is where you apply the ability to override. If your customer or internal user is asking, I want to use the 1 trillion parameter model, well, it may be a simple use case and they don't need to, and your router can override whatever the user selection is and route them to the simple, cheaper model to be able to deliver the exact same value to your business. And the governance layer here is just setting the budget. So your router is basically enforcing your budget and allowing you to execute with efficiency. There are a couple things we need to worry about. Where are tokens made? How are they used in the system, which is what use cases are they driving? And what value are they bringing to your business? These three tenets allow you to be able to make the decisions necessary and set the constraints forward for how you drive efficiency in this space. With that said, thank you so much for listening.